Hey guys, so we're starting a while, right? Yeah, so please, yeah. So we're starting in 3 minutes, okay? Hey guys, thank you for waiting. Welcome to our workshop. Blazing Fast Data Apps with Streamlit. I'm Ryan Tan, and I'm co-hosting with Theo. So, so many of you should be wondering, what will you learn in this very epic game of workshop? Well, you learn how to transform your data scripts into beautiful web apps, create interactive visualization with minimal code, build powerful data dashboard effectively, and deploy your app with just one click. Not really one click, it's more of like a line. So, so you might be asking yourself, why Streamlit though? Well, Streamlit is able to turn all of this, all of these stunning apps in just 5 minutes, not days, just minutes. You don't really need front-end knowledge. Front-end refers to the user interface, while back-end, which some of you might heard, also means the server, application, and the database that work behind the scene to deliver information to the user. It's only just pure Python magic, and it's instant deployment to the web. Now, some of you may be asking yourself again, well, why you guys have so much questions? What even is Streamlit? Well, Streamlit is a Python first web app framework, which means it mainly uses Python, and it's built specifically for machine learning and data science. It is open source. That means anyone can see, review, and edit the code. But there's actually more to that, but that's the general gist of open source. And it's backed by Snowflake, which is a company that supports what the dev are doing to Streamlit. So that means the Streamlit wouldn't just collapse in one day. Now, you may be asking yourself again, why not just use alternative like Dash or Flask or Gradio? Well, for Dash, it's more complex and requires HTML or CSS knowledge. Trust me, it's very hard to learn those. Flask a full web framework, so it has a steeper learning curve. And lastly, Gradio is great for machine learning models, but less flexible for data visualization. Therefore, Streamlit is the best. Also, Streamlit comes with a lot of integrations. Like there's an entire web page just for integrations. So that's why we're using Streamlit. Now, before we start, we do have some prerequisites. Don't worry, they are very simple. So for example, you need to learn, Python, Numpy, Matplotlib, which is optional, and Seaborn, which is also optional. Do note that if you attended any of our other workshops, all of the above content has already been covered. So now, let's set up Streamlit. Just a heads up, this workshop caters to laptops and desktops, preferably minimum 8 gig RAM and 20 gig storage. For the systems, we do support Windows, Mac OS, and Linux. And we also require you to have any modern web browser, so that is Chrome, Firefox, Safari, or Edge, Python 3.1 and above with pip, and last but not least, an IDE of Visual Studio Code. So let's move on to the installation walkthrough. Do note that if you're using any alternative technology, our ability to support you is limited, but we're happy to contact you. You're happy to contact our wonderful team to help out with any installation issues. So firstly, let's head to VSC and open a folder. I'm gonna do a live demo for you guys. So okay, you can see my screen, right? So we're gonna go to Visual Studio Code. So we can open up file and we can create a new file. And let's call it like, actually not file, let's create a folder first, right? So we go to anywhere you want and create a folder. For example, let's name it Streamlit, right? ABC for this case, right? So once you create a folder, we're gonna go to files, we're gonna go open folder, and then we're gonna go back to where we left our folder, and we'll open it up. Now, once that's done, we're gonna go to terminal by clicking this toggle pen over here, and we're gonna type pip install Streamlit. After that, you just enter, and it'll start installing. For this case, I already have installed it on my side, so it do take a while if you're installing it first time. So here's the command again. pip install Streamlit. And then after you're done, all you need to do is type back in your command line Streamlit hello. So if we go back here, let's just clear the terminal real quick. And we type Streamlit hello. And there we have it. This will pull out the demo page. So if we were to hit back to our slides, some OS specific notes you might need to have. Try to running command prompt or PowerShell as administrator if you get permission error. You should try py if Python isn't found. For macOS, use Python instead of Python 3. If you're using Homebrew, brew install Python 3 first, and your terminal might need full disk access under System Preferences and in Security and Privacy. So it's time for a simple debugging session for all of us to be on the right page. If you have no issue, just take a quick short break and we'll be back in 15 minutes. Okay, so if once you're done with pip install Streamlit, you can go to your terminal, right? Okay, don't worry. I'll do the live demo one more time. So you should have Python installed, right? So all you need to do is type install Streamlit to install it. And then it should install once you download everything. So in this case, I have downloaded it on my side, but it'll normally take a bit longer. Then to verify that it's running, it's working, you just type Streamlit hello. So I'll go back to the slide here. Yeah, it's fine. If you're using a virtual environment, yeah, you should be fine. If you're installing on, yeah, you need to install Python first. If you should have pre-installed it if you attended the previous workshop. Yeah. Does anyone have any problem? Yeah, feel free to have if you have any problem, feel free to actually voice out in the Discord channel for Streamlit, so we will be able to help you. Warning code. Okay. Uh, can someone take a look into that? How much space does it occupy? It doesn't really take a lot of space, but we do recommend like 20 gigs and stuff. To 20 gigs, but it's probably less than that. Okay. Um, okay. Okay, sorry guys. This is the interest of time. We have to continue, but do not worry. There are people still helping. We will still continue help as we continue the lesson. This video is, I think if I remember correctly, is being recorded, so you can still refer back to in if you don't understand. So we're gonna now download the workshop materials. Again, I'll be doing a step-by-step guide on how to do it. So let's go to the GitHub page that was given in the resource, which is this here, which is this link. And from here, what you need to do is click on code and download zip. Now you should be able to see this, which says GitHub example main-zip file. So this is the zip file we'll be using. So if you go to downloads, where I stored the main zip file, you guys will be able to. Oh, you guys are not seeing it. Give me a second. Whole screen, yes. So if you go to the, if I'm, for example, in my file manager and my zip file is here, I would shift it over to, let's say, remember the file I put. So I put it here, and I will just extract here. So this will extract the zip file to folders, and you should be able to see this. And yeah, to test it, all you need to do is you need to go back to the folder that we were in. So let's quickly shift it over. So you could open the integrated terminal in this area by right-clicking the file and then clicking on open the integrated terminal. Once you're there, all you just need to do is type Streamlit run 00 and then just press tab to auto-complete it, and the code should run. So this will be the workshop materials. So inside here will contain most of the codes that we will be teaching, as well as the example. So you can refer to this if you want to. So yeah, I'll give you guys a few bit of time. So we go to hub, which is in the thread with Streamlit resources, and then you just paste it here, and then we click on code to download the zip. Is everyone okay? Let's see how. So inside the workshop materials, we'll have an image folder that contains all the image used in the example, a page folder that contains 9 Python file, and 00_home.py, which is the landing page, the page you start with. So again, just in case you guys haven't already done it, just run streamlit hello, and you'll be able to see the official demo file for the Streamlit application. So inside this file, we will have, so it should look something like this if you did it correctly. If you didn't, you can feel free to ask in the Streamlit question for help, and we will be with you shortly. So what you can see in the Hello app will include a data frame demo, which contains interactive table exploration, a client-side sorting/filtering, and a dynamic data updates. And then you also will see a plotting demo, which has an interactive line chart with random data, a toggle between different chart types, and an adjustable number of data with a slider. We also do have a mapping demo with Uber pickup data visualization, a dynamic map filtering, and overlay with 3D height visualization. And lastly, it will be an animation demo with a live updating progress bar and animated movement. So if we were to take a look at the code itself, right, you would see that there is only Python, no HTML, no CSS, there's no JavaScript. It updates automatic code changes, maintains state between interaction, and scale simple scripts to complete app. So are you guys ready? You guys successfully learn how to use Streamlit, run your first app, and see what's possible. Are you guys ready to build your first app? So let's make our first app, a Hello World app. Get it? Because whenever you're done coding, the first thing you type is like print Hello World. So Hello World app, right? Yeah. So all we need to do is we're gonna simply head to our new file app.py. So and you type in this command, which is import streamlit st.write hello world, and run in a terminal. In this case, I named the file test.py, but it should be whatever you name the file, the Python file, and then you do streamlit run that file name. And that's it. Your first Streamlit app will be live. So let me just do another live demo. So if we were to head back to our file, right? And let's create a simple file called test.py. So in test.py, what we'll be doing now is we're going to type import. Let me just zoom in for you guys. We're going to do import streamlit st. And all we need to do is do st hello world. And we just save the file with Control S, or you can go file and save. Now once that is done, all we need to do is type streamlit run the file name, and we just enter. Now as you can see, it works. You should be able to see a page like this. That means you have successfully run your first web app. Now if we were to go back, we should see something like this. And now you might be wondering, what just happened, right? Well, let's actually break it down. So the first line is import streamlit st. What does it does is that we shorten streamlit to st for convenience, because we don't want to keep writing streamlit.write, or in other cases when we get on to other some of the text will be some of the functions will be very long and it's a bit inconvenient for us. So st just shortens it down so that it's easier for us. Next, st.write is just similar to the print statement, right? So st.write and then write hello world. As you see, we're using a string and it comes out like this. So later we'll dive more to what st.write can do, but just so you know, it's like a print statement. And st.run is the conventional way to run a Streamlit app. Okay. For you guys, right, if you guys are doing after Streamlit run, all you need to do is you need to type in the file name that you have been using. So in my case, I wrote my file name as test.py. So you run test.py. If your VS Code doesn't have terminal, all you need to do is you see on top here, the toggle terminal, or you just press Ctrl J. The zip file to download is my GitHub. Yes, the guy has sent the link. What do you mean by like before that? To open the Streamlit app is Streamlit Hello. So Streamlit Hello is the official Streamlit's demo page. Okay, I'll let one of our tech support to help you. So how to get terminal pop up? It's Ctrl J, like or the top fourth button. Let's see if I got the zoom tool. Oh, I don't have the zoom tool on my computer, but yeah, it's Control Z. Is this one on pop? Is this one? Or you press Control J. Oh, it's magnifier. Oh, thank you, thank you. So if we were to zoom in, uh, it's this one. It's this one. Yeah. Is everyone on the at least on the uh Streamlit Hello page, the one that looks like this? Oh, you know, not this one. This one. Can everyone get to this page first? Let's have a quick check. I will actually. I'll put out a poll. So, just feel free to do the poll if you have managed to do Streamlit Hello. Yeah. And yeah. Okay. So, let's assume, since I think you guys got it right. So we're gonna move on now to the Streamlit fundamentals. So the fundamentals is just basically the most basic stuff you will be using in the Streamlit app. So for this case, again, in case we'll be using Pandas and Numpy, but we're still focusing on Streamlit. It's just this tool will be used for data generation and analysis purposes. So before we start any app, right, before any applications, web app, we will want to set a page configuration. So that's where st.setPageConfig comes in. There are a lot of other parameters, but we're only going to show the three main one, which is page title, page icon, and layout. So page title is basically what you'll see at the top, followed by the icon, which will be the image, and then the layout can either be centered or wide. So if you were to see at this example here, after importing Streamlit, I set a page config and I call it hello world with a fire emoji. So it looks like this. Uh, remember our ST, right? So yeah, so ST is state. It supports a variety of formats from Markdown strings to Pandas framework, data frame, and accepts multiple arguments. Now, Markdown is actually a type of format that is used for like it's used in Discord, it's used in GitHub. But basically it's adding certain symbols to change how the text would look. So if we look at this example here, we're doing st.write hello, and then we do world, but then there's asterisks. So this will make it italic. And this here is how we make icon. It's a heart right emoji. So all you need to do is add colon, followed by the name of the emoji, and end up another colon. And you can write numbers, and you can also write data frames. So data frames, we have two. First column and second column. Then so this is the output of it. Okay, but which one do you guys need me to repeat? Type 51. Okay, set page config. Okay, so okay, from 31 onwards, right? Okay, so I'll repeat again because apparently I was lagging. I apologize for that. So set page config is basically in this example, as you can see, right? We are setting a page configuration, and then we need to set our page title. So in this case, you can set it as hello world, and then we set our page icon to a fire emoji. Right? So it looks something like this. Now moving on, we'll have st.write. So st.write is basically the print statement from Python, but way better. So it writes data to your web app. It supports a variety of formats from Markdown string to Pandas data frame. So Markdown is basically a format where you can change the way the text looks based on how you write it. It's a format, data and data panda frame is just data frame that uses panda that uses the panda library to help, and it has multiple arguments. So in this case, right, as you can see, we have st.write hello, and you see in hello world there is asterisk. So this makes it so that it becomes italic, and this is how you hard write emojis by doing semicolon and semicolon, and in the middle it will be the name of the emoji. And this is using and then the right panda data frames to generate a table. So it looks something like this. As you can see, woe is now italic and generates a fire emoji. There's the numbers. This is the data. Generates a table. Now, Streamlit has 4 levels of text string. So there's a title, there's a header, there's a subheader, and normal text. So it's pretty much quite straightforward. For title, you put title. For header, you put header. For subheader, you put subheader. And for normal text, you just do write. Now, you can use tricks to see performance indicators. So in this case, what happens is the first length is the title. So it'll be conversion rate. 3.2% is the final percentage, followed by plus or minus, depending on whether an increase or decrease, and followed by the number. Now, you know how to say pictures like 1,000 words? So you can actually add images to your Streamlit web by using the dot images. So there's actually a lot more arguments, but in this case, the main 3 ones you're looking out for is image. It could be a NumPy array, a URL to fetch the image from, or from a local path, and an SVG string. This one you don't really need to know, but it's good to, it's some web stuff. And then you have caption for image captions, and then there's width. So in this example, you can see I'm using a path this time. So I'm calling the image path, and this is the caption I have, followed by the width. Yeah, that's about it. So there's also, it's around the same format for audio and video also, because you can also add them. So audio uses both takes the data. So data will be your path file path or a URL, and then you can configure when you want to start it, when you want to end it, or whether it's there a loop. So in this example here, I use, for example here, because audio and video doesn't have any caption, so we use st.write to show you the captions, for example. So we have the song of Never Gonna Give You Up, and then we call the path here. So the path is images, and then we set the loop true. So whenever the song ends, it loops back. And here we have a video, and this time we add autoplay goes to true. That means the moment I load in this page, the video starts to play, and it loops also. Now, text and pictures are cool and all, but again, we are making a data dashboard, right? So you need to present to your code, right? And st.write doesn't really look good if you just write like that. So that's when st.code comes in, because st.code displays a block of code. And the body, so it will display the code. The language, you can set to any, but it's defaulted to Python. Line numbers shows the line numbers and it's defaulted to false. So in this example here, I'll be using a variable to store the code, the string instead. So I'm just doing a simple function to print hello there. And I write st.code, and I call the code variable, which is this one over here. The language is set to Python, and the line numbers is true. So you can see the line number here, and it shows the code. It keeps the tabs and the syntax highlighting, so it looks presentable. But then again, showing code is cool and all, but what if I want to see the output, right? That's when st echo comes in. Because using st echo, it shows both the code and the output. It has context manager usage, nested code functions, and functions definition. So in order to use it, you need to start off with the with st.echo, and then you put a tab, which is 4 lines, and then you can write whatever your code is here. So if you were to look at the example I have here, so as you can see, this code, this comment will not be shown lah, but if you write the comment at this line, it will show instead. So with st.echo, I create a function called test, and I make it return this value, and then I do st.write to run this function to bring out this value. So as you can see in the output, it shows the code and it shows the output at the bottom. Now, there's also st.markdown, which allows you to use GitHub flavored markdown. GitHub flavored markdown means it's markdown, but there's other things that GitHub added to make it so if you know how to use GitHub markdown, you can use .markdown instead. It also has unsafe allow HTML. That means you can use class.css to display if you know how to use CSS. And then help is additional tooltips that they can display next to the markdown. So in this case, I will be using block commenting or block strings. So here we're doing colon rate and then square brackets to basically tell them that hey, this line of code, I want it to be red, right? And then again we're using heart right emoji, which is using colon, the name of emoji, and colon. Same thing here. And then for highlighting in this case, we're actually using blue background to specify the color and then background. And the square brackets basically the word that's going to be highlighted. And then just a simple emoji. And this will be the output. So again, remember how I said there was like integrations you could do, right? So one simple integration we have is xt.lot. So what is Lottie? Lottie is actually a library that passes Adobe After Effects animation exported as JSON with body movement and renders them natively on the mobile and app. So it's just an animation. So in order to do it, you do need to install Streamlit_Lottie with pip install, and then you just import it. So from Streamlit_Lottie import st_Lottie, and then you just run the function st_Lottie with the URL of the file of the Lottie animation. So it looks something like this. So now that we've gone through the fundamentals, let's have a short activity. So using the function we've just gone through, let's make a simple about me pages, right? So it should have a short description of you, a set config page, a set config command, a title, an image, and a Lottie animation. Do know if you're having any trouble, feel free to type your problems in the Discord channel, and we'll be happy to help. Hey guys, so if you have any issues, please note them in the Discord channel. We'll be happy to help. We might take a bit longer because there is quite an influx of problems at the moment. Okay, guys. So I hope you guys have made your simple about me page. If we have to move on with the interest of time again, but again, if you're having troubles, feel free to type your problem in the Discord channel. And we did share the source. There is a solution in the Streamlit example GitHub page that we made you guys download for the workshop materials. So you can take a look at the code or take a look at the any of the examples we have given so that you can learn how to use Streamlit properly. So now we're going to move on to data display. So this section will cover JSON, data frame, table, line chart, area chart, bar chart, pie plot, and maps. Now, that seems like a lot, but because there is a lot, this is just a handful, a small section of it. So now you might ask yourself again, why not just ST write everything? Well, you shouldn't, because ST write actually guesses and guesses how to best render your data, and sometimes this becomes wonky and it doesn't really meet your expectation. So we should actually use specific Streamlit methods that helps better customize and modification. So we'll start off with .json. So JSON is actually stands for JavaScript Object Notation. It's just a way to actually store and handle data. And in this case, it's a very simple one if you look on the output here. Basically, it's an interactive JSON tree visualization with collapsible nodes. So as you can see, there's this small triangles at the side. You actually open and close it. It supports syntax highlighting and support nested structures. Now we'll be moving on to st.dataframe. So data frame displays it basically functions to display as an interactive table. There's multiple arguments, but we're just looking at this tree, which is data, width, and height. So width and height is optional, but it just asks you for your desired width or height. And there is data, so it's the data to be split. So in this example, it might look a bit scary at first, but don't worry, I'll guide you through step by step. So basically, we'll be importing random and pandas. Don't worry, random is just a library to create random values, and pandas is just the one that we use to create the data frame. So we're gonna call a variable called df, and we're gonna store it as a data frame using pandas one. So we're gonna have a name to contain roadmap extra and issues, URLs to contain the URLs, stars is for the stars over here, and view history to view random. The view history is just a bunch of random values over here. So we're going to call st.dataframe, and we're going to call the data, which is df. And this is just a configuration. So we see the thing in the top here is not the same because we're actually changing it. So we're going to make name into app name, as you can see. So as you can see, name roadmap extra issues. So it becomes like this, and it's called app name. For stars over here, we're creating a number column, and we're going to call it GitHub stars. Help basically means if I hover it over, it should show number of stars on GitHub. And format %d with the star icon is basically saying, hey, for the numbers inside star, I want to put a star beside it. So as you can see, it's like it ends up like this. For URL, we're going to call it app URL. And then we're going to see the view history. We're going to call it view in the past 30 days. And we're creating a line chart, as you can see over here. So it converts it into a line chart. And what it does, it converts, it makes it into a line chart, and we're going to set the minimum y value as 0 and maximum as 5,000. So it just looks cleaner on the table itself. And then we just hide the index. If not, at the side here, you have 0, 1, 2, 3. Now moving on, what if you just want a static table? That's when table comes in, and it's only one parameter, which is just data. So data is just the data you're going to throw inside. So in this case, in this code, basically we're creating another variable called df, and we're just creating a bunch of random values. And as you can see here, column is going to call %d again. %d again is to just say, hey, for this value here, I want it to be the first range one. So there's 5i, so 0, 1, 2, 3, 4, 5, because Python is 0 base index. So we start from 0. And then we just generate a bunch of random value, and then we just call it with st.table. So Now we're moving on to line chart. So again, it might look a bit scary at first, but don't worry, I'm here to guide you through. So basically, what it does is creates line chart for visualization. So we're gonna have our data, basically the data we're gonna use to draw the line chart. X, Y axis, just your axis. Color, width, and height is just for customization. So you can see in this example, we're gonna create another variable called line chart data, and then we're using a Pandas data frame to generate a bunch of, and then we use generate a bunch of random values, and we have column A, B, and C. So this, and then we just call it in line chart. So it creates a beautiful line chart like this. So you can actually hover on the lines and actually shows you the different values and the color. So the color is just the different people, so it's A, B, and C. So now moving on to area chart, which is very similar to line chart. So you can see the parameter are exactly the same. Data, X, Y, color, width, and height. But instead of showing a line chart, it creates an area chart instead. So this is how area chart would look like instead. Again, yeah, we're using the same values here, but instead we're calling it area chart. So now moving on to bar chart. Again, it's very similar to the other two. It's just the way we display the data changes. So again, using data XY, color, width, and height. And in this case, we are generating a bar chart. Now, what if I don't want to use Streamlit's version of creating charts? I want to use Matplotlib. Well, that's where PyPlot comes in. It creates histogram with the help of Matplotlib, right? So we have a fig, which is the data to be displayed, clear figure, which is the figure that we cleared after being rendered, and the last one is just arguments passed along to the savefig function. So this is just an example. We're going to import Numpy, and we're going to use matplotlib.pyplot as PLT. We just create a bunch of we create normal values, and then we create the subplots, and then we create histogram, and we just call the fig to create the histogram here. Again, if you're a bit confused, we do have examples in the workshop materials to see how it works, and you can learn from there in case you don't really understand. It's okay. So moving on to st.maps, right? So st.map displays a map with a scatter plot overlaid to it. So it's used for if you're using some geo display and stuff. So it's a bit confusing. All you need to know is very similar to actually the line charts and the other charts we show, but instead of XY, we're using latitude, longitudes, which are the coordinates of real life. You know your Minecraft XYZ coordinates. Yeah, we do have that in real life, but it's called latitude and longitudes instead. So data is just the data to be displayed. Latitude, longitude is the axis. Color, size, and zoom is just for customization. So some of the feature it has is that for the data formats, they do accept a bunch of random data. So we have you can do pandas data frame with latitude, longitude columns, GeoJSON geometries, or simple Python list of coordinates. And for customization, it has a bunch of it. We have map, box, style, maker size, scaling, color mapping by categories, and layer opacity control with custom tile servers and stuff. So this is just a very simple example. We're going to use pandas and numpy. Again, numpy is just to generate a bunch of random values, and this part is actually just the coordinates, and this is the points. So you can see we have a bunch of latitude and longitude, and then we just call the map of the variable. So it just looks like this. It's a simple scatter plot map on the map. So if we're going to use st.map, some of the performance consideration for using data sets, that means you're using like 10K points and above, right? Is that you might want to group it. You want to group nearby points together instead of showing them all separately. You want to summarize the data in advance to speed things up and make the map server-sided. That means you do the calculations on the server instead of the client, which is the computer or the people who's going to view your website. If it doesn't need to change often. And you might want to show more details when you zoom in and less when you zoom out to keep things fast. So now I teach you some of the basic data displays that we can use. let's add a simple template that we show you on the About Me page. If you have any issues, feel free to approach us and we're happy to assist you. The workshop materials do have the solution if you want to check. And yeah, 15 minutes. I'll see you there. Take a short break if you need to. So you guys can ask any question in the Discord chat if you have any problems, and we'll be here to happy to assist. Hi guys, just a quick consensus. There should be a poll that's still happening right now. Can you guys verify if you're able to run Streamlit Hello? I just want to get a sensing of how we are right now. Again, if you can't run Streamlit Hello for any particular reason, um, feel free to ask. Just ignore the guy that say just Google. Yeah. If you can't run it, please let us know and we'll be with you shortly. Also, we'll be finishing this activity in about 3 minutes. Hi, okay, so we'll be starting soon, but there's one more poll I would like to check. Can I know what's your please complete the poll of your operating system. Yeah. Thank you. Okay, so now we're gonna move on to widgets, right? So, cause you guys have now learned the fundamentals, so all the writing, text, code, and stuff, and we learn how to create data displays of like to show to show all the different uh data that you have coded out or mathed it out. So let's use widgets, right? So let's learn how a widget works, right? So a widget has a unique key, right? And it returns a value when you interact with it, and it triggers a script rerun on change. That means when something changes, like a user input, a setting, or file updates, the script runs again automatically, and it maintains state between reruns. Means it keeps data or settings even when the script runs again. So one basic example is the text input. So think of it as your Python's input function, right? So It's a label, which is a short explainer as to what it is in the output for, a value. So you can actually add the initial value of the text box. So like when it first render, right, you can add like certain text there. And you can do other parameters such as set character limits, placeholders, and autocompletes. So in this example, you can see it's just like an input. So you do need to call, you do need to use it, store in a variable. In this case, we call it title. And you do text input with a daily goal and example text is take a shower, for example. So you can see in this example here, it will look like this. And then we do st.write with an f at the front. So this is called f string. It's a way to actually format strings. So what I mean is that we're able to actually store use the variables, right? You know how there's print, and then if you want to like use the variable name, right, you need to do comma or you need to do a plus. Well, f string just void it all by instead making you do curly brackets. So you just put curly brackets and then the variable name to basically just show it out as you can see here. So in this case, we have touch grass also. If I change the thing touch grass, it now shows touch grass. Now, another one you can use is actually date input and time input. So it might look a bit scary to you, but don't worry, it's actually quite simple. So as you can see, we're going to do import datetime. So this is actually one of the libraries that come with Python itself. So basically, datetime is a way for us to actually mess around with, handle the time inputs and stuff, like time for computers, because it translates it into the computer version of time, which is a bit confusing, but it's for us to be easy. It's for us to make it easier. So as you can see here, I have and I call it time machine, and then I use emoji here. This is just an emoji. It's just an alarm clock, and then we have a subheader that just says travel the past or future, and we have put d as date, st.date input, travel date date to, and then you have a and we call the library, which is datetime.date, and this sets the date. And they have t, which is time. So we put time input instead. See how this is date input? We now have time input. So with the time input, we're going to do time to travel to, and then we use datetime.time instead. And we set the time in 24 hours format, and we just write it out. So it's something like this. Now, widgets, you can actually combine them. So as you can see here, what we're doing is just we're creating a simple data frame, a simple table here with names, age, and city. And then we set the minimum age, and then we use a slider. So this slider actually has a minimum age. So this is the title. This is 0 to 100, and this is basically how much you want to jump it by. 0 is the default one, means you jump by 1. And then cities, we're using a multi-select. And what we're looking for is any unique city variables in this area. So for simplicity's sake, there is no duplicates. But basically, if we were to scale this up, we want to only show the unique cities. So in this case, we will show New York, San Francisco, and LA. And then we do a filter. So filter, we're just basically checking the age limits inside here and only show those that are above or equal to the minimum age. If cities, so what this does is that if I did select anything inside, it will return a true. So you'll satisfy this condition and print out this line. And you could move on to this line, which is I want to set the filtered df to have check only the cities that's inside the cities variable. So if let's say my cities only has New York, it should only show New York people that is in New York, and then we write it out. So this is how it looks like. So you can see we set the minimum age to 25 and it shows everyone. And in this case, let's say I remove LA, we only show John and Jane and not Bob, because we never choose anyone that's inside LA. So that's how we can combine widgets in our data. So now there's something called persistent state. Don't worry, this is something that we will explain further on. But basically, you need to know that session state is like a dictionary. You guys do know what's a dictionary, right? Oh. You guys do know what's a dictionary, right? If you can't remember what a dictionary is basically a list which every value has a key. right? So something called a key value pair. We use a lot in dictionary, a key value pair. That's what we call it. So every key has a value. So in this case, right, in this code, right, what's happening is um, we check if counter is in session state. So we're looking for the key of counter inside session state. So our session state is a dictionary. If it's not inside, we create one. In this case, it's 0. In this case, we create it and set it 0. This is just layout for columns. So we explain more later in the layout section. And basically what we do, we have two buttons of left and right. And if it's clicked, we just increase the increment by or decrease by 1. And we just print it out by calling this value. So we call the counter key to print out the counter value. So another thing we have is a callback. So what callback is basically is we can actually just call back the value in the session state, right? So we first create a function which is on value change. What it does is that we just on session state, what we do is we change the message value into the selection. So, but what is this? Is down here. So as you can see, remember how I said that widget can tell that the key is selection. So we have a title called pick a number, and this is the number values that you can pick from. So when when on change, we call this value change function. So when I click any of this number, what happens is I'll clock this function to kick in, and what it does is I take any of the values here and I store it inside the session state of the value of the key selection. I know it sounds a bit confusing, but that's what it does. Oh, selection box. Okay, so for selection box, right? So this is the title. So it's a pick a number, and this is the numbers we can pick 1, 2, and 3. And he has a key called selection. How every widget has a key, right? And what happens is that we do something called on change. So when I select any of these numbers, what happens is I'll call the function on value change. Get it? Yeah, you guys understand that part? Uh, yeah, okay, someone understand. So when this function, what this function is that we have a value, we have a key called message, and this message will get updated with selection. So basically what I do is I store the value inside this session state. That's inside this session state. That's how callbacks kind of works. And basically this line just checks if I did create a value, if I did create a key called message. If I didn't, I create one. We do have this example in the workshop materials. So if you don't understand, you can just play around with the code. It's you guys can edit and play around with the code and from your own knowledge, because session state is a callback is a bit tricky, but it's quite useful. Also, session state date is for storing data that will persist after changing page. So if let's say I'm in a data display page and I go to let's say I go to home page, the data still stays the same. It doesn't change. However, if you were to refresh the page, everything disappears. In order to save that, we will dive more about it later. I think we do talk about it. So now that we're done with this, now that we've read through the basis of widgets, this is just a few widgets that we have. There's a lot you can see. You can see in the official documentation that we leave at the end. You can now create a widget in your About Me page. So let's try to make the page more interactive and live. Again, we'll be giving you maybe 10 minutes in this case because of time. And again, if you have any difficulties, just ask. We'll be free to help. All right. So I hope you guys. So I'll now be passing over the time to my co-host to explain the other stuff. So layouts. Yo, I think your mic is muted.
Okay, thanks for telling me that. Thanks to Ryan for doing such an amazing job in the first half of our workshop. I will now cover the layout section of this presentation. We have thus far covered how to interact interactive data, displays, and controls into your Streamlit application. Now, you might think that you have all the necessary tools at your disposal, but there's more to building web applications than that. I will now go over Streamlit's utilities for organizing your data application and why you should use them. Now, why would you want to use containers in your application? Containers offer benefits in terms of organization. Take a look at the following illustration of a typical web page. The example on the left has visible boundaries separating content of the same function, while the example on the right does not. This results in poorer readability for your users and can be regarded as bad design practice. In real-world applications, containers are also used to adapt a web application's layout to better fit the device screen. Containers also allow for development of web UI templates with a more consistent and interconnected interface for programming. Looking at the illustration again, you can clearly see that multiple elements are duplicated. In practice, this also means that a lot of the styling code and event code are shared between containers. Borrowing an idea from the Intro to Python workshop, you can then think of containers as functions, reusable blocks of code. Containers allow for many different user interfaces to be built from many such reusable blocks of code, each for their own specific purposes. The fact that they are all built on the same structure, containers, means that learning the fundamentals will allow you to understand what any interface does, regardless of how complex it is. Now, why is Streamlit's container programming interface good? The age-old argument, of course, is that they are simple to use. That is everything in Streamlit. The types of containers offered by Streamlit are kept to only the most universally used options across front-end libraries, and customization is kept to a minimum. It is also perfectly valid for you to consider this a fault of Streamlit, since it lags behind other more comprehensive frameworks and does not have the same magnitude of third-party support to balance this. However, since the focus on the hackathon is on data analytics, it is enough that you present your findings clearly, something Streamlit is capable of accomplishing with little effort on your part, and is very important to consider when you have limited time in the hackathon. We also believe that what we teach you today for Streamlit containers can be easily transferred to any UI/UX library you may learn in the future. Next, I'll cover the most basic container Streamlit has to offer, which, rather confusingly, is also named the Streamlit container. In my experience, it is the layout that you may end up spamming all over your Streamlit application if left unchecked. It is a generic box in which you may dump any and all of your data displays as you wish. You will use Streamlit Container for the following reasons. Often, you may find Streamlit Container useful for grouping data displays and widgets with a common purpose together. It is also a quick way to add padding between different regions of your web application. Streamlit offers the following options for adjusting the style of the container. Height, which sets a specific height to the container in pixels. If not set, the container will resize to fit the Streamlit components it contains. You may also enable display of a border around the container. Let's now cover an example of usage of the Streamlit container. You can see that we are using the with syntax to declare that any code executed within will be done in context of the container we have passed. In this case, we will write a green colored text indicator and a bar chart into the container, and a red colored text indicator outside the container. The output is as follows. You can see that there is a visible boundary between the red text and the contents of the container. You may enable the border if you wish to make a stronger distinction between the contained elements and the rest of the web page. I will leave this slide on for you to digest this for a short while. Okay, now we may move on. Here is an example of code that requires a container. When creating web applications, it is good practice to label functionality. However, in this case, there is little separation between the header and the rest of the Streamlit widgets. To fix this, we can edit our code to wrap our widgets in a container, excluding the header. From earlier, we know that inclusion of a container automatically creates padding between its contents and the rest of the web page. Here, there will be padding between the header and the widgets and a border as well. Here's another example. Think back to the Google Forms feedback they've done for us over the past workshops. If the title of our Google form, let's say Introduction to Streamlit, was placed just above the text of the first question, what do you rate our Streamlit project, Streamlit workshop as? Will you think that the title was actually the first question on first glance? That is why it is important that you make such considerations in the hackathon, even if you don't end up using Streamlit. When our panel of judges grade your work, you definitely want them to have an easy rather than a hard time using your prototype. To summarize, Streamlit containers are very useful for grouping widgets of the same purpose. However, it is very important that you do not overdo nesting of containers, as this may lead to an overcomplicated web app design. To add on to what I have taught today, I suggest use of Streamlit Pydantic, an external third-party library created by other users of the Streamlit application. This library allows for definition of containers using Python classes. This provides a more intuitive and object-oriented means of creating components, such as cards or other reusable components, rather than placing your creation code in a function. I will leave you some time now to digest what I have taught you about Streamlit Container. All right, now we can move on. Now, before we move on to the other types of containers, I will cover this once. Streamlit containers usage, as we have covered here, can be extended in some cases, in fact, most cases, to the other containers. This is evident, especially in using the with syntax. So, for Streamlit sidebar, you would run with st.sidebar in order to insert elements into a sidebar, then add the contents of the Streamlit sidebar within the code. So, in future code examples, we will be using the with syntax and understanding and expect that you will understand what it means. Now that Streamlit Container is done, we're moving on to Streamlit Sidebar. In the course of this workshop, you likely have noticed the left of your Streamlit app has been something we've barely touched on. Well, that stops here because you're going to learn how to make use of it. In Streamlit, the sidebar is designated for two purposes: navigation and data display controls. We will, for now, not be covering navigation and instead focusing on how Streamlit Sidebar can allow you to add any Streamlit component to a centralized control panel for your application. First off, to add new components to the sidebar, unlike the other layout components in this section, we will not be creating a new sidebar. You may wonder why that is the case. This is because, it may be a surprise, but your sidebar already exists. In your Streamlit application, and in fact every Streamlit application, a grand total of only one sidebar will always be present. This is commonly referred to as the singleton design pattern, where the accessor Streamlit sidebar is a singleton. You may use this accessor in a with clause similarly, or alternatively, you are also capable of creating any Streamlit component in a Streamlit sidebar using .accessor syntax. This is with the exception of a few outlier Streamlit components. Streamlit echo and spinner must themselves be placed within a with clause, and hence it is syntactically infeasible to use them in a sidebar. A toast is displayed independent of the rest of the application, and hence it does not make sense to insert it in a sidebar. Let's now cover an example of usage of the Streamlit sidebar. As shown in the previous slide, sidebar being a singleton does not prevent us from using it in a with clause. In the example shown, we add controls to adjust the theming of our application and to adjust the height and width of some component. We also demonstrate that you are capable of adding not just widgets, but also containers like Streamlit Expander into our sidebar. Streamlit Expander being something we'll cover later as well. And this is the end result of the code from the previous slide. It can be seen that the components are appended row-wise into the sidebar. In the case of overflow, the sidebar will also have a scroll wheel. However, in case of the page sections overflowing, over here, the page sections will also have a scroll bar that can be scrolled independently of this section. To further build on your understanding and understand I am willing to use Streamlit sidebar, here's a situation where its usage may apply. You have in front of you a Planner application for your BuildingBloCS workshop. In your code, you have a number of controls dictating the range of data you wish to present in your data app. You could simply place these widgets at the top of your application. However, if you have upwards of 10 different data displays controlled by these same widgets, it will be a hassle for the user to have to repeatedly scroll up, down, and up again to use the basic functions of the application. In that case, we can insert it in a sidebar. These controls are now permanently on the left side of your screen, allowing your consumers additional convenience in using your application with just one line of code. Let's round off this part of our workshop on Streamlit sidebar by summarizing what we've learned and listing some additional information that you should keep in mind. We discussed the use of Streamlit sidebar as a control panel and its applications. We now further advise that the controls to be added to the sidebar should be prioritized and kept to a minimum. Too many controls in the sidebar would detract from its purpose for quick access, requiring the user to scroll to find the control that they are looking for. We leave it an exercise for the participants to figure out how many widgets added is too many. Lastly, we want to emphasize that the Streamlit sidebar is a feature unique to Streamlit. Other web frameworks do have the ability to implement sidebars, but it is not compulsory. Now that we've wrapped up our content on Streamlit Sidebar, let's move on to the dialog layout. A model dialog is a container that appears over the rest of the application, disabling all other input and focusing the application on the dialog. I'll discuss the syntax of Streamlit dialog. Streamlit allows you to set the header of the dialog and select one out of two widths for the dialog. You may notice that out of the blue, we found a rogue add symbol. Oh, excuse me. Sorry. We've found a rogue add symbol in our Python code. It wasn't covered in the introduction to Python workshop, so we're going to be covering it now. And I guess you could treat this as Intro to Python Part 2, since we're going to be focusing on pure Python right now. So, the add symbol you've seen earlier in this slide is actually called a Python decorator. What is a Python decorator? The code on my current slide sees it all. We have a function called greet, and within it, we have a print call with a string hello world pass. If we ignore the decorator, our code will print hello world, and that will be it. But let's now look at the decorator function. In it, we can see that the decorator function takes a function magic as argument, and itself returns a function wrapper. In wrapper, we call magic and execute a print before and after the magic call respectively. So, to summarize, decorator takes a function and allows code to be executed before and after it. So what happens when we use add decorator on our greet function? Python, before even turning this function into machine code, we'll first pass it into our decorator, creating a wrapper around greet. This new wrapper function will then replace the original greet function. The final result is that execution of greet will first print before calling the function. Then it will run our original greet function right here, and afterwards, it will print after calling the function. It could be said that our decorator annotates the original function, adding new code to it, and making it an entirely different function. Decorators exist for many reasons, but we'll cover a few major ones in the following scenario. Let's say you wanted to check the execution time of certain parts of your code. You could choose to edit code directly and paste in a lot of time calculation statements. But doing so is not only tedious, but adds the risk of conflicts with your pre-existing code. Decorators excel in such scenarios for the following reasons. They are incapable of modifying your original code, therefore, will have predictable and consistent behavior across users. They are also very simple in implementation when you are accustomed to them. Therefore, Streamlit has made good use of them in Streamlit dialog. In the following example code, we can see that Streamlit dialog is always used as a decorator on a function. The function will contain every component we wish to add to our model dialog. In the Streamlit library, the Streamlit dialog decorator will take our model dialog function, run necessary code on it to build a model dialog for us, then add the contents of the function, some widgets, to our model dialog. This allows for some unique behavior when compared with other layouts. Streamlit will only rerun the dialog function instead of the script on user input. This allows for many dialogs to be present in a single Python script without incurring significant overhead. Now that you've had a crash course in Python decorators, let me guide you back to Streamlit. Here's some Streamlit dialog code that generates a web page for participants to vote for the best workshop. In the dialog, we first execute Streamlit write, and then afterwards, we have a text input and also a submit button. You may notice that here we have a line called Streamlit rerun. This is the recommended method for closing a dialog. Upon running votes, a dialog with title Cast your votes will be generated, and you get to say your reasons for liking your favorite workshop. Following our previously established reasoning for the appropriate use of dialogues, use of a model dialog would be appropriate in this case if the page where this dialog lives was an overview of the workshop details. And after all that, this is the result of our code. You can see that besides the components we have added, Streamlit has taken the liberty to add a close button to our dialog. You may also press the escape key to close the dialog. To close off on our dialog section, we will first cover some important technical behavior of Streamlit dialog. Streamlit dialogs are capable of interacting with the main page. This means that variables and functions that are declared outside of the dialog function may be accessed within the function itself. This is because such variables and functions belong to the global scope, a feature of Python. As we have covered previously, dialog functions will execute independently of the rest of the web app when the dialog is opened. Therefore, any reference to the global scope is done each time the dialog is opened. This behavior can sometimes be useful, but we advise against it, since it introduces poorly defined functionality to your code, which will make debugging an absolute pain. Another important point is that one dialog can be opened at any time. This is intuitive, given the knowledge that dialogues break away from the web app content to be focused on, something that cannot be done if there is a second dialog in the way. I will now take a break and let you all digest the content of Streamlit dialog before moving on to Streamlit columns. All right, we are back. And now let's move on to Streamlit columns, a means of grouping your widgets and data displays into two columns. Here, you can see that the syntax is rather simple. First, you have spec, which controls the number and the width of your columns to insert. You may pass an integer or a float to the spec parameter. Secondly, you may also adjust the gap of your columns, and it defaults to small, but you can also set the gap to large. Here's an example of using Streamlit columns. In this example, we want to load two images of manga portraits into your Streamlit application. However, as we have discussed in the previous slide, it looks more aesthetically pleasing if the manga portraits are lined up in a row for the user of the website to compare. This is where Streamlit columns comes into play. We create a column of two rows and insert a header and the image into each column. And here is the end result. Now, let's take a look at this example. Unlike our previous examples, it isn't immediately obvious that there is something wrong with our layout. The web application consists of a number of text inputs followed by a text area. Right now, we want to evaluate the quality of the UX design in the terms of our consumers. This is not unlike a Google Forms layout, so surely it can be bad. Well, as with every other slide thus far, I'm signposting that something can be improved. Let's think about who our target audience is. It's obviously people who are studying for some kind of test. It is custom to write your answer for an MCQ to the right side of a question. However, in this case, our button to submit is printed below the MCQ. This is unintuitive and furthermore takes an unnecessary space in a web app. Thankfully, columns will allow us to modify the behavior and move the submit button to the right, which is more in line with the experience of our target users. Again, we come to the end of another part of a Streamlit component. This time, I only have one advice to give you. You should be wary of the behavior of Streamlit columns on different screen sizes. On a smaller screen size, Streamlit columns will have a responsive behavior. What this means is that since Streamlit is unable to display two columns side by side, it will wrap the columns, displaying the first column at the top and then displaying the second column below the first column. Therefore, it is advisable that you do not make interfaces that depend on two columns being next to each other. After all, you don't know if the judges will be grading you on their phones. Next, we are moving on to the Streamlit Expander. You can think of it as an extension of the container, except that it can be closed and open. This allows users of your Streamlit application to choose which parts of the website to focus on and ignore the rest. Here's an example of usage of Streamlit Expander to display a distribution of dice numbers. We also include an image. This image and its caption are unimportant to the main content of the web page, so it makes sense that we will put it in an expander to reduce clutter. However, I must clarify that it's also not a good idea to spam expanders all over a web app, since it could result in a very messy interface, something that we will cover when we move on to Streamlit tabs. Here's the output of a code from the previous slide. Upon clicking the See Explanation tab, the content of the expander appears via an animation. Note that this will cause the elements below the expander to be moved downwards, which may be an issue if, for instance, you're placing this expander in a fixed width container. Here is another example where expander is applicable. This is an example code representing controls over the displays of a generic matplotlib graph. While it could be argued that this is a relatively simple interface that hardly needs an expander, your hackathon project may require many data displays on the same web app, introducing complexity that could be removed by placing all controls within expanders for their respective graph. And so, here's the output code. Moving on, to close my thoughts on expander, let's go over some fun facts. Expanders are often referred to as accordions outside of Streamlit. More accurately, an accordion can be thought of as an stack of expanders, and they are effectively the same layout as an expander. Different web frameworks will sometimes have different names for the same component, which you should take note of when browsing documentation. Secondly, being able to set the expanded status in an expander can allow for programmatic control over which sections of the web app the user should focus on. This can be used for showing relevant sections of a form or for making a landing page showcase of your app's capabilities. It is now time for us to meet Expander's strange cousin, Streamlit Popover. It serves precisely the same function as Expander, a means of minimizing content to be shown on user requests. However, the presentation is entirely different, as we will soon see on the next slide. Here's an example of a popover component. On clicking the button, the container appears over the rest of the web app, similar to Streamlit dialog. So, how do we make a decision on whether to use Streamlit Popover or Expander? Well, Popover is typically used for more compact interfaces, and similarly to Streamlit dialog, should also contain an interface that breaks from the flow of the Streamlit application. Meanwhile, Expander typically uses larger interfaces and does not break from the flow of the application. Last but not least, we have Streamlit tabs. Streamlit tabs are effectively like the tabs on your browser. To create a Streamlit tab, you will pass in a list of strings, and each string will represent the name of one tab. These Streamlit tabs will return a list of tab objects, and each tab object can be used as a container. Let's take a look at an example of using Streamlit tabs to make a rudimentary image carousel. We have an image of a cat, a dog, and an owl. The content, in this case, fulfills our previously established reasons for using Streamlit tabs, which is to arrange content that are similar that we don't want to view all at the same time. So for instance, we will only want to view one cat and probably not the dog and the owl at once, because this is after all an image carousel component that we're trying to replicate. So we are using tabs in order to display each of the components only at once, which saves space and allows us to make the interface easier for the user to read. And here is the output of our code on the previous slide. It is now time for us to do a hands-on activity. Refer to the shared repository that we have sent in Streamlit resources. There should be a file, all4layout.py, containing encode and instructions. It's honestly optional whether you want to do this activity, but the point of it is to give you some time to practice using what we've taught you. During this time, you may also choose to ask questions if you want to using our Discord channel. At the end of 10 minutes, adjusting the time for time, I will go through my solution. Enjoy.
Hi guys, quick sanity check. Yeah, just do the poll. Hey guys, sanity check polls. Please do it. I just want to see how many people is on alive. They haven't lost their minds. Understanding our workshop. Um,
Okay, I believe that 10 minutes has passed and now we are back. I know I said earlier that I would be going through the solutions. However, in view of the time constraints, we will simply be posting our solutions at the end of the workshop. We apologize for this inconvenience and hope that you will still enjoy the rest of my presentation. Next, we'll be moving on to the theming section. Why do we want theming in our web page? Theming is capable of enhancing the experience of the user when using your application. It also allows your application to appeal to a specific target audience. Different groups of people may have interacted with some web interfaces more than others. When designing your web application, you should take some time to read up on such user needs. Not doing so risks alienating your consumers with a web application that is unintuitive for them to use. To expand on this, let's take a look at an example. This is Streamlit's default theme. It is extremely minimalistic and while still visually appealing, doesn't do much to stand out from other Streamlit applications. Then, let's look at a different example, this time of the theming of an actual website. Disclaimer, this website does not use Streamlit, but is nonetheless a good case study. Of note is that use of the same color for almost every component in the website, not having a highlighting color like in this version of the website. In the theming, you can observe that they use shadow styling, as in this button, and slight variations of color, as in the table that is being displayed here, to create boundaries and indicate presence of different components. Now let's look at a different example of this website called Stack Exchange. You can see that the design is very utilitarian. There is a lack of advanced styling like shadows, and it only uses single tone colors to denote different widgets within the website, such as this button here or this panel here. Similar to the previous slide, space is also used economically, fitting a large amount of functionality into a single screen. We hope that such examples will give you ideas on how to improve the design of your own web application. So, how do you run your Streamlit application? Firstly, run the Streamlit app as you have earlier in the workshop. You will notice that in the upper right-hand corner, there is a triple dot icon. Click on the icon and navigate to the option named Settings. And to clarify, because I misspoke earlier, right now what we are doing is that we are trying out the theme preview feature and we are not running the Streamlit application. I'm sorry for misspeaking. Click on Edit Active Theme, which will bring you to a dialog, which will allow you to preview the theme of your web application. I will now give you all a few minutes to play around with the settings to customize your application's theme, and possibly if you have any issues, you may also voice them in the Discord chat. Okay, we're back and now moving on. Earlier, this section is just to educate you on how to preview a theme for your website. It does not actually modify the theme of the website. And this is something that I'll be demonstrating to you right about now. So I'm going to demonstrate how to change the theme of your Streamlit application in Windows. And give me a second and I'll just bring over VS Code and delete my config file from earlier. Now, this should be the same pin repository that you have downloaded from our GitHub page earlier. In order to add a theming to your web application, you have to do the following. First, create a new folder called .streamlit. And I spelled it wrong. Awesome. Next, inside .streamlit, you want to create a new file called config.toml. This is a configuration file that is used for various different settings within Streamlit and not just for theming. But for today, we are going to be using it to adjust Streamlit's theme. So first, we will enter in right square bracket, theme, and then left square bracket. This will indicate that we are adjusting the theming settings for our Streamlit application. Next, we are going to write primary hang on, even I need to check the documentation sometimes, which is rather unfortunate. All right, I was correct. You have to enter primary color, and then this will set the primary color, which perhaps I will go back to the slides to demonstrate. The primary color in this case will modify the highlight colors that you see in your Streamlit application. For instance, if your primary color is red, it will color this section of in this text and this tab red. If I set it blue, it will perhaps color not just this, but also the highlighted radio button here blue. There is also an option for adjusting the background color, which if I go back to, not this. If I go back to VS Code, you can also adjust the background color. And let's say we set it to white because I'm currently in dark mode. So this will make it pretty visible. Let's set it to green. Very red. Let's do this. Just to demonstrate that you can use hex codes as well as just names. So we're going to run our Streamlit app now, which is 00 from pi. And you can see that I have set everything to white. And perhaps if I were to find an element that has the highlight color, yes, you can see that I have set the highlight color to red, or rather the primary color to red, and that has modified all of these different components to adjust hex code FF0000. I'll give you some time to try this out on your own, but if you have trouble achieving this, you may do note that the recording of this entire workshop will be posted at the end of the workshop. So if you have trouble, you can still rewatch what we do and learn from the process that I've demonstrated here. And now, moving back to the presentation. Skipping through back to where we are, there was a segment for doing a demonstration for Mac/Linux. However, I don't believe we have enough time to go through those, so apologies to people who use Unix. There is a note that we have for people who are deploying their Streamlit app to the cloud. Perhaps you're using Streamlit Community Cloud or some other external service. You have to be certain to upload the config.toml file with it. because certain services will choose to exclude folders beginning with a dot. Now, you may have noticed that Streamlit itself only offers minimal control over the theming of your web application. If you're interested in exploring more advanced theming concepts, you may consider looking for third-party libraries such as Streamlit Tailwind. You may also refer to the material design documentation website for design best practices and tips. Moving on, we'll now discuss navigation and creating pages within your web application. Currently, your Streamlit application only has one main page. Streamlit provides components for you to designate multiple pages within your web application. We want to create applications with multiple pages for much of the same reason we want layouts. Layouts separate the different functionalities of your application. Well, pages simply operate one layer level higher than that, containing groups of functionalities that together can help the user achieve some goal. In this slide, you can see that we have your typical Streamlit application. Notice the folder called Pages right here. This is a specially designated folder by Streamlit in which you may create pages for your application. When a new Python source file is placed in the Pages folder, it is interpreted as a page and is linked in your left navigation bar. The contents of each of these Python files are much the same as the one in your app.py. That means that you can create pages seamlessly by simply just writing a new Streamlit page as you would for a normal app.py file. Why then do we use Streamlit pages as compared to the routing systems present in other frameworks? We've had one of those pro and cons slides earlier, and to save you some time, the fundamental reasoning is that again, because you're in a hackathon, you have limited time. Streamlit takes every measure possible to remove boilerplate from the typical web framework process, even at the cost of less power to customize your web app. Let's not go over it. As discussed earlier, Streamlit allows use of the special pages folder to define an app. However, you may choose to define your pages manually using Streamlit Navigation and Streamlit Pages. This is because the pages directory does not work with subdirectories, at least if you are using Streamlit applications. Streamlit pages are initialized with the following parameters. You can set the title of the Streamlit page as it's displayed on the browser tab. You can set the tab icon and a relative path to the website page. Here is an example of an application of pages to make a dashboard. In alignment with our established purpose for pages, we choose to separate our dashboard according to the needs of a user. A bugs page is made for a user who wants to submit a bug report. This is separated from an alerts page, which is created for users who wish to view alerts. Moving on, Streamlit pages, when created, are passed to the Streamlit navigation component. This component must be called in the Python file you run your Streamlit application call from, which in this case should be app.py. You are permitted to pass a list of Streamlit pages or alternatively a dictionary of pages if you want to group pages into subdirectories. We will demonstrate the use of a dictionary in the next slide. You may also choose to hide the navigation content from the sidebar. Here's an example of passing a dictionary into the Streamlit navigation component. In such a scenario, you will access each page like reports/dashboard, which is the relative path from your local host, or tools/search, again the relative path from your local host. Now, the text on this slide may be rather small, but that's because I've compressed 3 entire pages into one single file, just to show how impractical Streamlit app dev would be without pages. Splitting your website content into pages, therefore, will also make sense from a developer standpoint to compartmentalize code into multiple small files for easy understanding. We will now cover Streamlit page link, a text element that when clicked on will redirect you to the page specified. It accepts the following parameters. Page, which again is the relative path to the page that you are linking to. Label, which sets the text of the link. And icon, which sets the icon to display next to link text. And here is an example of how Streamlit page link allows you to insert a hyperlink into the page. Additionally, Streamlit also provides switch page, a means by which you programmatically change the page display to a different one for the user. Now, there is a short activity here, but again, in view of the time constraints, we will be posting the solutions for this short activity and highly encourage you to try this on your own. Instead, we will be moving on to Section 9 for state management. Websites are capable of storing information about the user interacting with it. As can be seen in this screenshot, upon loading the website, it has stored the following information about its user. Why do websites do this? Sometimes you will have to store information specific to the user interacting with your website for various purposes that interacts with the functionalities of your website. For instance, when logging into a website, the website will store an authentication key as proof that you have the permission to access your account's content. Websites may also store information about the user preferences, such as whether they prefer to be on light mode or dark mode. Websites may also store frequently used information, such as website thumbnails, so that they don't have to be re-downloaded from the website every time we navigate to a new page. There are many ways you can store data in a server. The first is by using URL parameters, as seen above. Streamlit also offers a quick utility for obtaining the query parameters, which is called Streamlit query underscore parameters, which is demonstrated in this slide. So in this code scenario, if we run Streamlit query parameters first key equals to 1, we would do something if our browser URL has a parameter first key equals to 1. The same will apply for this code example, and this code example instead is a means by which you can set the parameters of your browser URL. Browsers are also capable of storing information in request headers, which you can access by doing this Ctrl+Shift+P on your browser, and then going to network, and then scrolling down and viewing the request here. I will leave you to try this out on your own time. Websites are also capable of storing data in their cookies, which you may access by performing the following actions. Again, I will let you try this out on your own time. The same applies for this if you want to look at cookies involved in requests. Streamlit offers the capability to modify cookies, headers, and also parameters also URL parameters as we have shown earlier. This is an example of how you may modify cookies and headers. If you want to check your session state, it is also easy to view as you can use Streamlit.write to print it to your web page. Here's a code example of how you will delete items from your session state, such as a header or perhaps a cookie. And also, you may control the session state using text input. Here, you can see that we have added a parameter, key equals to name. This means that when we enter something into our text input, it will adjust the element in the session state with a key of name, whether it be a header or cookie, to be have the content of whatever we input in the text input widget. Here's a more complicated example for you to digest. Here, we have a slider a checkbox, and a form submit button. In the slider, we are capable of inputting a number from 0 to 10, which will adjust the value of a key in my slider. Here, the checkbox will also do the similar thing for my checkbox. That is all for the state management chapter, and now let's move on to static file serving. When prototyping your hackathon project, there may be cases where you need to store files other than your datasets. For instance, if you wanted to store an image, it is convenient to store all your images on a server, then load them via a relative path. Now, you might be thinking, why can't I just copy and paste my images into my project and refer to them that way? While it is intuitive, that is not how Streamlit file hosting works. When you run your Streamlit app, your project is processed to turn into this. It will only contain app.py and you only contain app.py and the files that are relevant to hosting your server. So it will not have contain node modules, .env, .streamlit, .git. None of these will exist. Now let's add some static files to your project. You have already created a config.toml in our previous chapter. So now you may enter the following text into your config.toml file in order to enable static file serving. I won't demonstrate this because it's rather simple if you've already done the original creation of config.toml. Just add the following text. I'll leave it on the slide for a few seconds. Next, go to your Streamlit project and create a new folder called static. Under that folder, you can add any files that you want to be placed in the server. So, in this specific case, I will be placing cat.png, robots.txt, and staticdata.json in the local directory of the server. Now, go to your Streamlit app in the browser and add the highlighted text to the website URL. Going to that URL will result in the file being displayed, as can be seen here. Your static file can now be used in Streamlit components such as Streamlit Markdown, Streamlit Image, Streamlit Video, among others. We're almost at the end of the presentation, so I want to cover something that is perhaps something that we wanted to cover but didn't really have much of a time to do so. I will now open my Streamlit app and demonstrate something for all of you to try. And it closed. That's fine, honestly. Oh, okay, this one works. So here's our Streamlit app. And as you can see, it contains a lot of the examples that we will be posting later. And over here, I believe we've been looking at the Streamlit app for a long time now, and maybe you've already noticed this. There is a button called deploy. Now, I don't know what this does, so let's click on it. Deploy this app using Streamlit Community Cloud. That's interesting. Let's do it. Oh, sign in. Do I even have an account? Let's try this. Oh, and you can sign in with Google. Okay. Careful to not accidentally dox myself, perhaps. All right, and you can see here that I have a GitHub account and it's been linked to my Streamlit accounts, and I am now able to upload a Streamlit project to the Streamlit Community Cloud. So let's authorize it. And this is technical difficulties now because I have 2FA enabled. And I'm going to take a minute just to access the 2FA code. Okay, awesome. I'm going to attend this really quickly because, all right, nice. It wasn't even censored. Gosh. Okay, let's deploy this app now. Let's say this branch main. Well, I don't have admin permissions, unfortunately, because this is Ryan's repository, but this we will come to this page, and presumably, once we are done filling in everything, we will be able to deploy our app. And this will allow anyone, including the judges, to easily view our app without having to run any of our code. So you should be considering this if you were to use Streamlit in your hackathon project. And moving back to the slides, that is everything for our Streamlit workshop. Thanks to all of you for attending. If you have any questions, you may send them in the chat now. And for more information, you may refer to the Streamlit documentation, which is linked here. Oh, and I didn't expect it to actually link me to the Streamlit documentation. Here are some alternative resources. Oh, this is just a default slide. Who left this in? I apologize for the
Everyone
technical
deleting this.
difficulties
Everyone
again.
deleting this. Oh no. Yeah, but yeah.
We're both blind. It's unfortunate.
Yeah. But yeah. If you guys, I think we still have a bit of time. So yeah, we have
We
feedback.
have 7 minutes, and those 7 minutes are enough for you to give us feedback in the form
Yeah.
that we are flashing now on the screen. So go ahead and give us feedback. And we'll also be here and addressing some of your concerns.
Okay, so I put out a poll if you guys want a live demo on the config file for Linux and Mac OS. So yeah, if you don't need, it's fine. If you want, it's okay. There's only 7 people that use Linux. So why is there more than 7 votes? Guys, are you guys lying in your polls? Okay, looks like there are yeah, there's a bunch of people saying yes. Okay, I'll give you guys 1 minute to finish up the feedback form. Then yeah, I'll teach you guys the Tomo config file. So I'll be using Linux. My distro will be Kali, but it should be the same throughout most of the Linux distributions. I think it's the same for Mac OS. I might be wrong. If I'm wrong, I'm sorry. Okay, that's 1 minute, I think. So I will take over. Okay, so I'll be taking over. I think he bugged out.
You want to take over? Is that...
Yeah, I took
Oh,
over. To
wait, I'll
take.
just stop sharing screen. Wait, actually, I don't think everyone's done with responses, so
The
I'll
link
just leave
is
it on.
in the Discord server channel, anyways. So
I'll just read.
anyways,
Okay.
Yeah. Yeah, this is Kali. As you can see, I'll do some simple Linux commands to make sure, guys. So basically, what we're going to do is just gonna cd, and we're going to do /.streamlit. So the wonderful thing about Linux is that it can find it immediately, right? So as you can see, in this case, I did create a config file already, but you can always just do it with nano .toml. You can also do it with touch, but this creates a blank file, and you still need to access it with like nano or vim or text editor of your choice. So if I were to, I think I already did create it. Oh, I didn't. Okay. If I have to nano the config file, all you just need to do is you can add your theme, and then you can fill out with all the items that you want to type in. Yeah. So that's how you basically do it on Linux. You just go to the directory and create it. You can also do it on any text editor that you're using. So that's it. It's pretty simple. So with that, I think we may have come to the conclusion of our presentation, our workshop on Streamlit. I think once you're done with the feedback, you should be free to go. I